Okay, so let's start adding a little bit more to the complexity. Analyzing the next one, we are talking about a tangent graph. A is equal to 1, so there's no vertical stretching or compression, and we're not adding anything, so C is equal to 0. So really, as far as Y is concerned, nothing's really happening for this graph. But we see that B is equal to 2, and D is equal to pi over 4. This causes a new period. The new period is pi over 2. And this basically makes us shift to the right pi over 4 units, right? Since we're subtracting, that means the shift's actually going right. And this is all impacting the x. So when we go graph this, again, the idea is to manipulate data, right? So on a typical tangent graph, we have negative pi over 2 to positive pi over 2. And then we have negative pi over 4, 0, and pi over 4. Asymptote at the end, negative 1, 0, and 1. So there's our data on a normal tangent. All of this is impacting the x, but what we first do is we do the b. And we're going to divide by 2, which means we're actually multiplying by a half. So my new data after that, right, we still have an asymptote, negative 1, 0, 1, and we still have an asymptote. This will give us negative pi over 4, negative pi over 8, 0, pi over 8, and then we get pi over 4. All right, so that handles that. So A wasn't around, C wasn't around, we just handled B. Now what happens with D? Well, we take all these x values and we add pi over 4. All right, and so some of them will have to do a little bit of work, but I think we can see some of them are pretty clear. Right, so if we add pi over 4, well, negative pi over 4 plus pi over 4, that gives us a 0. Right, negative pi over 4 plus pi over 4, excuse me, negative pi over 8 plus pi over 4, we need to do a little bit of work there. This is negative pi over 8 plus 2 pi over 8, and that makes us a positive pi over 8. If we add pi over 4 to 0, we're at pi over 4. If we take positive pi over 8 and add pi over 4, this would be pi over 8 plus 2 pi over 8, which is 3 pi over 8. And then if we added pi over 4 to pi over 4, we would get, let me write that out, pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. And so you can basically see really clearly that new period, right, from 0 to pi over 2. So we got a period change. Everything's been shifted. You can even see we're starting at negative pi over 4, now we're at 0. So everything's been shifted to the right. Asymptote, asymptote, negative 1, 0, 1. So there is all our data. So let me come down a little lower. So what's this tangent graph look like? Well, along the x-axis, right, we basically have 0, and we have pi over 8, and we have pi over 4, and we have 3 pi over 8, and we have pi over 2, right? And if you wanted, you could break that up and we'll eventually run into pi, right? Or we can come back here and have negative pi over 2. I'm just getting ready to sketch some more cycles if we want to. Where's our asymptote? Well, one is at 0, and the other one is at pi over 2. At pi over 8, we're negative 1. At pi over 4, we're 0. And at 3 pi over 1. So what's this tangent graph looking like? It's basically looking like that. All right, and again, I think this would be 3 pi over 4 here, right? It would look like that. And back here would be negative pi over 4, and it would look like that. So I sketched 3 cycles of this tangent graph after just graphing 1, right? But there you have it. So again, manipulate data like crazy. How about I try doing the next one together here? So in this case, A is 1, right, and C is 0, so Y is not being impacted. Our B is equal to 1/2, so that means we're taking a new period and we're actually multiplying by 2. So the new period is 2 pi, and then we're subtracting pi over 2, so that means we're going to the right pi over 2 units. This is all impacting x. So taking our data, right, what's our data for a cotangent graph? Well, 0 to pi pi over 4, pi over 2, and pi over 4. All right, asymptote, asymptote, 1, 0, negative 1. So y is not being impacted, but as far as x, we have to start with b first. We divide by 1/2. Of course, that means we're actually multiplying by 2. So when we do that, right, we get 0, pi over 2, pi. Oops, I think I forgot to write a 3 there. 3 pi over 2 and 2 pi. So you can see that we've been stretched out to 0 to 2 pi. Right? We have an asymptote, 1, 0, negative 1, asymptote. Now that we've handled b, the next thing is to go to d. Right? So now we're going to add pi over 2 to all those x coordinates. So x and y. In this case, if we add, we get pi over 2. Pi over 2 and pi over 2 is pi. Pi plus pi over 2 is 3 pi over 2. 3 pi over 2 and pi over 2 is 4 pi over 2, or 2 pi. And then that's going to give us a 5 pi over 2 when we add it to that. Asymptote, asymptote at the end, 1, 0, negative 1. So there's basically the graph. All right, and then let me go ahead and I'll just sneak it in over here. I'll use some new paper. All right, and so when I go graph this, we've got our x-axis. Let me put my y-axis here. We're over here at pi over 2, and then we're at pi, and then at 3 pi over 2, and at 2 pi, and 5 pi over 2. Right? And then 1 and negative 1 respectively. So from my sketching, we know we have a vertical asymptote at pi over 2. We have another one at 5 pi over 2. At pi, we're equal to 1. At 3 pi over 2, we're 0. And at 2 pi, we're negative 1. And so there's our graph of the cotangent with all that shifting. Right? And if you wanted more, you would just shift that over and just draw it again. And draw it again and draw it again. But I'm just going to do one because I'm almost 10 minutes or 8 minutes into this and I don't want it to get too long. So there you have it. So again, it's all about manipulating the data, right? A and C impact Y and B and D impact X. You manipulate the core data points on a graph and then you basically sketch your core data points. You can't lose in terms of your scale, right? And in this case, there's no extrema, but you can definitely nail your x-intercepts and all that good stuff, right? So I'll try to make it even harder in the next round of videos.